We're going to start off with the statement of the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Now this has a lot of words and a lot of clauses, and so typically students think of this in terms of the picture. Let's start with a right triangle. We will label the legs A and B, so the length of this leg is A, the length of this leg is B, and the length of the hypotenuse is C. And so what we want to do is we want to think about the words. The sum of the squares of the lengths of the legs. Well, these are the legs, so the length of the legs are A and B. The sum of the squares of the length of the legs, the sum of the squares of A and B, A squared plus B squared, is equal to the square of the length of the hypotenuse. The length of the hypotenuse is C is equal to the square of the length of the hypotenuse. And this is the formula that most students are familiar with when it comes to the Pythagorean theorem. Now, when we use the Pythagorean theorem in this class, we're just going to be applying it, so we're not going to focus on the proof so much. There are lots of intuitive proofs, graphical proofs that you can see online if you look around for it, but really we're going to focus on the application of it. And when we have those applications, we want to focus on this picture right here. We will always be drawing this picture, making sure that we have the legs and the hypotenuse labeled correctly, so that when we apply the formula, we apply it to the right parts. Our first application of the Pythagorean theorem will be the derivation of the distance formula. Now you may remember the distance formula from a previous math course, but sometimes students in their memories, they get the plus signs and the minus signs mixed up and everything. And so by thinking through the derivation, it gives us the opportunity to fix those things rather than just hope that we've remembered it correctly. So we're going to start off with 2 points. We'll call them x1, y1 and x2, y2. So these are the 2 points, and we are interested in the distance between them. We'll call that distance d. Now, when we look at it in this framework, there's not a lot that we can do, but once we draw in a right triangle, this gives us access to the Pythagorean theorem. The only thing we need to do is determine how long this leg is and how long that leg is, and then we can plug the numbers into the formula. Now, figuring out how long these lengths are is something that actually pulls on knowledge about the number line that goes way, way back to, I don't know, very early in your math careers. So if we look at this point here, the x-coordinate is x1, and this point here, the x-coordinate is x2. And so the question becomes, if we have 2 points on the number line, how far apart are they? So let me just do an actual example here. How far apart are the numbers 5 and 2? Now we could manually count this out, 1, 2, 3, they're 3 apart, but you might also remember that we can determine the distance between two numbers by taking their difference. So 5 minus 2 is equal to 3, and 3 is this distance between them. And so this tells us that subtraction is the way that we determine the distance between two numbers. And so what we can do with that is see that this distance here is x2 minus x1. And the same thing happens in the y direction. That height is y1, this height right here is y2, which means that this length right here is going to be the difference between those two, y2 minus y1. And so now we have a right triangle. This is one leg, that's another leg, and that's the hypotenuse. So, we get the first leg squared plus the second leg squared is equal to the hypotenuse squared, right? The Pythagorean theorem, the sum of the squares of the legs, of the length of the legs of the right triangle is equal to the square of the length of the hypotenuse. And so we have this formula, and we are interested in solving for d. And so to solve for d, we have to just take the square root of both sides. I'm just going to do that right here. Take the square root of d squared, that gives us d, and this is the distance formula. Here's a quick example of an application of the distance formula. Find the distance between the points, -3, 2 and 2, 5. Now, even though it's not completely necessary, I find it's helpful to sketch a picture of the situation. So -3, 2 is right here. So here's -3, here's 2, -3, 2 like that. And then the second point is 2, 5. So 2 this way, 5 this way. So that's point 2, 5. And we're trying to find the distance between them. So when you draw the picture like this, you can see that we've got the numbers labeled on the number line and things like that. And this helps us to understand the whole picture and help us put things together. Sometimes if you make arithmetic mistakes, you won't catch them. But if you look at the picture, things won't quite line up. And so the formula says that the distance between the 2 points is equal to the square root of a bunch of stuff. And you have to remember what the distance formula says. Now, one thing that's really important, and where drawing a picture really helps, is that it gives us the opportunity to label the points. Sometimes when students are looking and reading problems, your brain will scramble these two numbers, and it happens, it's okay. But if you label the points 1 and 2, it helps you to keep your focus and not lose track of things. So it's going to be x2 minus x1 squared plus y2 minus y1 squared underneath the square root. And so this is equal to square root of x2. So we go to the second point and we look at the x-coordinate of the second point. 2 minus x1. So x1 is -3, first point x-coordinate. Squared plus y2, which is 5, minus y1, which is 2 squared. Subtracting a negative is addition, so 2 plus 3 is 5, 5 squared is 25, plus 5 minus 2 is 3, 3 squared is 9, 25 plus 9 is equal to square root of 34. Now we can do a quick check. 34 is equal to 2 times 17, and so there are no square factors there, so we can't simplify that any further. And so this quick calculation using the distance formula, there are a couple things to think about. One of them is this mistake right here. Oftentimes students, if they're going quickly, they'll just do 2 minus 3 and they won't get the right answer. Remember that it didn't come up in this problem, but a negative number squared is positive. That is a mistake that I sometimes see. And over here in this picture, we can actually identify this 2 minus -3 we said is 5. That was this horizontal distance. And when you look at the picture, it makes sense. 5 minus 2 was 3, and that's that vertical distance there, and that also makes sense. And so this is how having the picture can sort of help make sure we don't make mistakes. And so the distance between these 2 points is the square root of 34. One quick observation about this problem. If we were to label the points differently, so this point is point 1 and this point is point 2, and we were to work it out, it will still give us the same answer. So this distance is equal to x2 minus x1 squared plus y2 minus y1 squared, square root of all that. It's equal to square root of x2. So this is our point 2 now. The x-coordinate is -3. -3 minus 2 squared plus 2 minus 5 squared. It's equal to the square root of -5 squared plus -3 squared. And since a negative squared is positive, we have 25 plus 9, which is still square root of 34. So even though we numbered the points differently, we still ended up with the same answer. And all of this comes down to the fact that if you swap these two numbers, x2 minus x1, if you swap the numbers, you'll get the negative of the previous answer. But since when you square it, it becomes positive, it all sort of washes out in the end.